Hello everyone, welcome to another class of Fundamentals of Electrical Circuits. Today we're going to discuss about the sinusoids. So this is an introduction to AC analysis, the alternating current circuit analysis. Okay, so as for the introduction, we will differentiate the difference between the direct current and alternating current. So before we are discussing about the direct current circuit analysis, so today we will be focusing on the AC analysis. So let's review what is direct current. So direct current is electricity flowing in a constant direction and or possessing a voltage with constant polarity. So by the name itself, direct current, so it has only one direction. Then for alternating current, so it is a flow of electricity which reaches maximum in one direction, decreases to zero, then reverses itself and reaches maximum in the opposite direction. So by the definition itself, you can imagine that the alternating current considers a positive alternation and a negative alternation. So we have here the representation of the direct current and alternating current. So for direct current, the direction of electron motion looks like this. So we have the flow from positive to negative, and we have here a switch. So as you might have observed, if the switch is open, so the flow of the electron stop. Okay, because the switch in our circuit acts like a bridge to connect the flow of the electron from one point up to the another point or the other side. Okay, but for the alternating current, so if we have an AC source, so the flow of the alternating current reverses from positive alternation and the negative alternation. So we will consider two alternation when solving circuit. Now let's define what is sinusoid. So a sinusoid is a signal that has the form of the sine or a cosine function. A sinusoidal current is usually referred to as the alternating current or AC. So such a current reverses at regular time intervals. We have a regular time intervals and has alternately positive and negative value. So circuits driven by sinusoidal current or voltage sources are called AC circuits. Yeah, now I have here a sinusoid. So this is an example of a sinusoid. So from 0 to 360 degrees, we have here one wave cycle or the period. This is the time interval. Okay, so as you can still remember, if you will consider a unit circle, one revolution represents 360 degrees or 2 pi radian. So this is the same with this wave. So from 0 to 360 degrees, that is one wave cycle. And we have a frequency that's the reciprocal of the period or equal to 1 over t. So our unit for frequency is what? Hertz. Okay, so unit of frequency, hertz. Unit of period is second because period is time. Now we also have distance. If we will compute for the distance from this point up to this point, so we have the term wavelength. Okay, so we have a formula for the propagation velocity that is equal to the wavelength, that is lambda over f or over frequency. So propagation velocity is equal to lambda over f. Then n is equal to c over vp. Our vp here is the propagation velocity. N is the refractive index of a material. Then lambda is equal to c over f. So this is the relationship between the wavelength and the frequency. And of course, c is the speed of light. So you can check your calculator. We have the value of the c stored in the constant. Okay. Now we have different values of AC. peak value, peak-to-peak value, instantaneous value, average value, effective value, or the RMS, or root mean square. Now let's start with the peak value. So peak value is the maximum value of a waveform of one alternation, either negative or positive. So peak, maximum. If we have here a graph, so what is the peak value of this graph? That is 4 volts because the maximum value of either the positive and the negative is the same. So that is from 0 to 4, we have the peak value of 4 volts. Now for the peak-to-peak value, that's the magnitude of a waveform from the peak of the positive alternation to the peak of the negative alternation. So considering the same waveform, we have here this peak-to-peak value equal to 8 volts. Now for the instantaneous value, that is the value of current or voltage at one particular instant. So if you want to measure some points in the waveform, so for example, we want to measure the value of the current or the voltage at this point. So the value that we will get is the instantaneous value. And it is denoted by V of t equal to Vm sine of omega t, where Vm is the amplitude of the sinusoid. Amplitude is the height of the waveform. Then omega is the angular frequency in radians per second. And omega t is the argument of the sinusoid. So omega t, that is the angular frequency multiplied by time. Then we also have the average value or the average of all instantaneous value during one alternation. So we have a formula for the average value equal to 0.636 times the maximum value. Then for effective value or RMS, root mean square, that is the value of alternating current or voltage that will have the same heating effect on a resistance as a comparable value of direct current or voltage will have on the same resistance. So formula for the effective value, that is I effective is equal to I max over square root of 2. So same with the voltage, so VRMS equal to V max over square root of 2. Now we have form factor and peak factor here. So for form factor, that is the ratio of RMS value to the average value of an alternating quantity. For peak factor, ratio of maximum, okay? Maximum value to the RMS value of an alternating quantity. Okay, so we have again the key term, right? So peak factor, the numerator is the maximum value. For form factor, RMS over the average. Now let's consider the sinusoidal voltage V of t is equal to Vm sine omega t. So as you can still recall, this is the formula that we have earlier in the instantaneous value. So our Vm, again, that's the amplitude of the sinusoid. The omega is the angular frequency in radians per second, and the omega is the argument of the sinusoid. So if we have here a sketch of Vm is equal to sine omega t, for letter A, that is as a function of omega t. Then for letter B, as a function of t, or the period. So it is evident that the sinusoid repeats itself every t seconds. Thus, t is called the period of the sinusoid. So on our figure, so from 0 to pi, that is the positive alternation. Then pi to 2 pi, that's the negative alternation for letter A. And that completes the wave cycle. For the letter B, we have 0 to t over 2, then t over 2 to t. That's why it is evident that the sinusoid repeats itself every t seconds. and t is called the period of the sinusoid. So from the two plots, we observe that t is equal to 2 pi over omega, because this one from 0 to t, so this is equivalent to 0 to 2 pi. Okay? And our t is omega t. So omega t is equal to 2 pi, and omega t is also equal to the period time. So that's why t is equal to 2 pi over omega. So we have here the formula for the period. So the fact that v of t repeats itself every t seconds is shown by replacing t by t plus capital T in the equation above. So we get v of t plus t is equal to vm sine of omega of t plus t is equal to vm sine omega of t plus, so we replace the capital T by the 2 pi over omega. So Vm sine omega t plus 2 pi, that's equal to Vm sine of omega t, or equal to V of t. Hence, V of t plus capital T, or the period, is also equal to V of t. So this is just the mathematical representation of how the value of V of t is the same for every t seconds. And so that is v has the same value t plus t as it does at t, and v of t is said to be periodic. So in general, a periodic function is one that satisfies f of t is equal to f of t plus n times capital T for all t and for all integers n. So as mentioned, the period t of the period function is the time of one complete cycle, or the number of seconds per cycle. The reciprocal of this quantity is the number of cycles per second, known as the cyclic frequency of the sinusoid. Thus, our frequency is equal to 1 over t, or the reciprocal of the period, and omega is equal to 2 pi f. Okay, so from our equation a while ago that t is equal to 2 pi over omega and f is equal to 1 over t. So therefore, our angular frequency, that's equal to 2 pi times f. While omega is in radians per second, f is in hertz. Let us now consider a more general expression for the sinusoid. V of t is equal to Vm sine omega t plus phi, where omega t is the argument and phi is the phase. So both argument and phase can be in radians or degrees. Now let us examine the two sinusoids. V1 of t is equal to Vm sine omega t, and V2 of t is equal to Vm sine omega t plus phi. So if we will graph these two sinusoids, so we will have this kind of graph. And as you can see, this one is the V sub 1. This is the Vm sine omega t. And this broken line is the Vm sine omega t plus phi. So our V2 is advanced by an angle phi. So they have a phase difference of phi. So a sinusoid can be expressed in either sine or cosine form. So when comparing two sinusoids, it is expedient to express both as either sine or cosine with positive amplitude. So this is achieved by using the following trigonometric identities. So sine of A plus or minus B, that's equal to sine A cosine B, plus or minus cosine A sine B. So this is sine cos cosine. For a cosine, so cosine of A plus or minus B, that's equal to cosine of A cosine of B minus then positive sine A sine B. So that's cos sin sin. So with these identities, it is easy to show that if we have sine omega t plus or minus 180 degrees, that's equal to negative sine omega t. And if we have cosine omega t plus or minus 180 degrees, that is equal to negative cosine omega t. And if we have sine of omega t plus or minus 90 degrees, that's equal to plus and minus cosine omega t. For a cosine omega t plus or minus 90 degrees, we have negative then positive sine omega t. So we will use these identities to convert our sinusoid to have a positive amplitude. Okay, so for example, we get a negative sine omega t. So to convert the sinusoid into positives, we'll have to perform this one. Sine omega t plus or minus 180 degrees. Now let's consider the sample problem. So find the amplitude, phase, angular frequency, period, and frequency of the sinusoid. So we have v of t is equal to 12 cosine of 50t plus 10 degrees. Okay, so from our formula a while ago, we have v of t is equal to Vm sine or cosine omega t plus phi. Okay, where Vm is the amplitude. So our amplitude here is equal to 12. Okay, let's write amplitude is equal to this one, 12 volts. For our phase, so our phase is the phi, right? So our phase here is equal to 10 degrees. For our angular frequency, that is omega. Then our omega here is omega t. We have 50t, therefore our omega is equal to 50 radians per second. For our period, t is equal to 2 pi over omega or 2 pi over 50. Okay, and this is equal to 0.1257 seconds. Then for the frequency, okay, frequency is just the reciprocal of the period 1 over t. So we will have 7.958 hertz. Ayan. Then for the next problem, given the sinusoid 5 sine of 4 pi t minus 60 degrees, calculate its amplitude, phase, angular frequency, period, and frequency. So for amplitude, again, we have 5. Okay, 5 volts. For phase that is equal to negative 60 degrees. For omega, that is 4 pi radians per second. So take note of the unit always. You must not forget to write the units. Then period, that is equal to 2 pi over omega or 2 pi over 4 pi. That's equal to 0.5 seconds. And for frequency, that is 1 over t or 1 over 0.5 equal to 2 hertz. There you go. Now let's have a sample problem. Calculate the phase angle between V1 is equal to negative 10 cosine omega t plus 50 degrees and V2 is equal to 12 sine omega t minus 10 degrees. So state which sinusoid is leading. So as you can see, we have here a negative amplitude for the V1 and it is cosine, while the V2 is positive but it is in sine. So in order for us to know the difference between the phase angle of these two sinusoids, they must be the same. So if we want both cosines, we have to convert this one into cosine and the V1 must be converted into positive cosine. Okay? So let us use the identities we have a while ago. Now our V1, so let's say we will convert both into cosine. Okay, so if both into cosine and V1 is equal to negative 10 cosine, so this is the identity that we will use, negative cosine omega t. So to convert it into positive cosine, we'll have to use positive or negative 180 degrees. Okay, so V1 equal to negative 10 cosine of omega t plus 50 degrees. So this will be equal to 10 cosine of omega t plus 50 degrees plus or minus 180 degrees. So, V1, let's say that's V1 prime, equal to 10 cosine of omega t. 50 plus 180 is 230 degrees. Then the other one, V1 2 prime, that's 10 cosine of omega t. 50 minus 180, that is negative 130 degrees. Okay, so this is for V1. Then for V2, 12 sine omega t minus 10 degrees. If we will convert sine into cosine, so we will use this one. Since we have a positive sine, we will use the negative here. So cosine omega t minus 90 degrees. So our V2 prime will be equal to 12 cosine of omega t minus 10 degrees minus 90 degrees. Therefore, our V2 prime is equal to 12 cosine of omega t minus 100 degrees. Ayan. So, you can find the difference. We can just use this one, negative 130 degrees, since they are both negative and it's easy to see the relationship. For phase difference, let's just subtract. Since V2 is the phase angle of V2 is greater than the phase angle of V1. Let's say that's V2 minus V1. That's negative 100 minus negative 130 degrees. And that is equal to 30 degrees. Therefore, our V2 leads V1 by 30 degrees. V2 leads V1 by 30 degrees. And if we want to use both in sine, okay, so let's see, both sine. So our V1 equal to negative 10 cosine of omega t plus 50 degrees. So negative cosine to sine, okay, this one. So we have negative cosine. We will consider the sine minus 90 degrees. Okay, so our V1 prime will be equal to 10 sine of omega t plus 50 degrees minus 90 degrees. Then V1 prime equal to 10 sine of omega t. 50 minus 90 is equal to negative 40 degrees. Then our V2 equal to 12 sine of omega t minus 10 degrees. So our V2 phase angle is still greater than V1. So our phase difference equal to V2 minus V1. Negative 10 minus negative 40 degrees. That's equal to positive 30 degrees. So the same, V2 leads V1 by 30 degrees. So, it's up to you if you will convert it into both cosine or both sine, because uh, the same process will, the process will just lead to the same answer. I mean, so 30 degrees. Another example, find the phase angle between I1 equal to negative 4 sine 377t plus 25 degrees and I2 equal to 5 cosine of 377t minus 40 degrees. Yan, so if both cosine, let's say both cosine. So I1 equal negative 4 sine of 377t plus 25 degrees. So we have negative 4 sine and we will convert it into cosine. So this one, negative sine, we will convert into positive cosine. So we will have to use plus 90 degrees. So our I1 prime is equal to 4 cosine of 377t plus 25 degrees plus 90. Okay, so I1 prime is equal to 4 cosine of 377t plus 115 degrees. Then our I2 equal to 5 cosine of 377t minus 40 degrees. So let's subtract phase difference. That's I1 minus I2. And that is 115 minus negative 40 degrees equal to 155 degrees. So our answer, I1, since I1 is greater than I2, therefore I1 leads I2 by 155 degrees. Okay, so let's check if both are in sign. So our I1 equal to negative 4 sine 377t plus 25 degrees into sine. So we have negative sine. So this one, negative sine. We can use positive or negative 180. So I1 prime is equal to 4 sine of 377t plus or, plus lang pala, plus 25 degrees plus or minus 180 degree. So it can be 4 sine of 377t, 180 plus 25, 205 plus 205 degrees, or 4 sine 377t, 25 minus 180, 25 minus 180, that is equal to negative 155 degrees. Then for I2, we have 5 cosine of 377t minus 40 degrees. Convert cosine into sine. So this one, we have positive cosine. So we will have positive 90 degree. Positive plus 90 degree, I mean. So we have I2 prime equal to 5 sine of 377t minus 40 degrees plus 90 degrees. So our I2 prime is equal to 5 sine of 377t plus 50 degrees. Now, since this is positive, we will just consider this one. Okay, so our phi difference, that is I1 minus I2 again. We have 205 minus 50 degrees. And that is equal to 155 degrees. So, the same answer. So, I1 leads I2 by 155 degrees. Now, we have sum of alternating waves in phase. If we have in phase or the same angle, phase angle, we have I2 is equal to I1 plus I2. So, just summation of the amplitude. Then out of phase by 90 degrees, we can use Pythagorean theorem. I2 is equal to the square root of I1 squared plus I2 squared. Then if we have out of phase by acute angle, so if we have two different phase angle and it's an acute angle, so to know the sum, we can use cosine law. That is I2 is equal to the square root of I1 squared plus I2 squared minus 2I1 I2 cosine of 180 minus theta. And that is the end of the discussion for the sinusoids.